than there is at Howlett. And so this would be some more evidence of deeper soil development being influenced by that climate gradient. Depth to carbonates, these were the average depth to effervescence and counting carbonate minerals at these sites. Howlett 49, Wilden 65, Avon Lake in the south, at least 155. Now actually at Avon Lake, we didn't probe deep enough to actually find the carbonates. Our deepest core was 197 centimeters, but the average probing depth was 155. And so this is calculated, basically, we make these estimates of the mass of total carbonates removed to these depths. This one would be greater. So in this column here, this is in megagrams per hectare of carbonates removed from that zone that is missing those carbonate minerals. So to a depth of 49 centimeters, we've lost 1,600 metric tons per hectare of carbonates. And just to give you an idea of that size, and I think, April, we were talking the other night, is that's like 400 semi-trucks full of corn or something, roughly, to put that into perspective. We also wanted to establish a trend for the depth to carbonates, so to what depth they've been leached to. This is where we kind of branched out of just strictly looking at the research locations and actually collected more of the data that's available for these outwash soils across the Des Moines lobe. So I actually pored over soil surveys and found, because in the soil surveys in the back they have actual soil data for real profiles that have been examined, and they tell you the depth of carbonates, so it's a real world sample. And so I pored over all these Des Moines lobe counties, picked out some of the common outwash soil series. Now these would be like, some of you might have heard of these, but Esterville, Wadena, Cylinder, Linder, and forgetting one. I think Salida is the one I'm thinking of. So I looked up information for these, or the data, and averaged it out for these counties. Now I made several maps similar to this. Some of them I amalgamated all of the data, so I treated all the outwash soils equally and just got an average depth. Those ones were more messy. When I just looked at the average depth of, say, the Cylinder series or the Wadena series, it was a little bit neater to see the trend. As you can see, the averages kind of bounce around, but it's still consistent enough that we're able to manually fit these isobars. And of course, the Des Moines lobe and the Des Moines River, you can see how we've plotted here 60 centimeters to depth to effervescence, 70, 80, 90, and 100. And it follows along that northwest to southeast increase in precipitation. So, and across this distance from the northwest corner of Emmett County to the northwest corner of Polk County is 200 kilometers. And over that distance, we dropped 40 centimeters, or increased, 40 centimeters our depth. So we could say that roughly every 50 kilometers, if you're moving from the north-northwest to the south-southeast, that depth to effervescence, that depth to carbonate minerals in the soil will increase 10 centimeters. So that utilized data that I collected also from the soil surveys. Kind of wrapping things up. Results support the null hypothesis. Loamy soil textures in the surface horizons that were found overlying those sandy coarse textures could be explained by waning flow following a high flow event during the late Wisconsin. Bettis and Hoyer, 1986, studied the Noah Creek Formation in depth along the Des Moines River and described like three, I don't want to say members, but the three portions that make up the formation that is the Noah Creek. They had like cross-bedded sands at the bottom, then gravels, lots of gravels that they interpreted, this is the middle portion, they interpreted as a catastrophic flood event. So maybe like an ice-dammed lake was released. So they have this massive surge, high energy surge deposits, lots of gravels and stuff. And then the uppermost portion is more loamy, and they described as a waning flow following, or an overbank deposit following that high flow event. So that could explain why we have these loamy textures. And we don't really absence of stone lines. So a stone line would be, say, where if we had formed the soil out of all of that middle member. So we're trying to see if that loamy stuff formed from that middle member or if it's a unique deposition. If it was all that middle member, if that continued to surface, you'd expect, since there's very little pebbles and gravel in this in those upper horizons, you expect those to be dropped down, say by bioturbation. You'd see a concentration of gravel and stuff. You'd have very little, a lot, and then you'd have kind of an even distribution. We don't see that. Pseudomorphs, there's very few of them. Pseudomorphs I described again as like a rock breaking down. That would be evidence of strong weathering, chemical and physical weathering, that's breaking down this large stuff to small stuff. And there was very few well-developed profiles. Like I said, very few argillic horizons. So it's interpreted the profile characteristics are primarily inherited from the parent material, that outwash. Results that we found that kind of confound the null hypothesis. Some physical and chemical weathering, of course, has happened. There were some, you can see evidence of things breaking, the smaller stuff. We did, of course, dissolve carbonates. I mean, there are depths to carbonates. If we assume 25% at time 0, you've lost a lot of mass, and then you've also increased the clay fraction. Carbonates don't usually in the soil exist in the clay fraction. They're more prevalently in the sand, pebble, coarse stuff, and some in the silt. So if you actually dissolve away these carbonates, you're not dissolving away the clays. You're dissolving away the larger stuff, and so this is going down, the large stuff, and the fine stuff, if you release those clay-sized impurities, is coming up. So you kind of have a two-pronged attack, sort of. Deeper soil development was also observed along that climate gradient. I showed you the soil organic carbon that increased. Fewer of those colorless minerals at depth at Avon Lake. So these are interpreted to have some influence, would be the secondary cause of producing these finer, loamier textures over these coarse textures. Conclusions. I'm basically just going to read this right off the slide. I try and paraphrase, but I'm going to read this right off. Particle size data and observations of morphology support the null hypothesis that loamy soil textures observed in the surface horizons are largely due to geological, not pedological processes. However, there's certainly influence of pedological processes in generating finer surface textures overlying the coarser textures. Across the soils of the 3 research locations, trends and data for soil organic carbon, mineralogy, and depth of carbonates were observed, showing evidence of the influence of the mean annual temperature and mean annual precipitation climate gradients. Any future research, it'd be great if we could actually do those point counts to get a better idea of the mineralogy. Those are very time consuming, but they give you some great information. Also, particularly the ratio of feldspar to quartz. Feldspar is a little less stable than quartz on the Earth's surface, so you'd expect that to break down a little bit more rapid. That would we could learn some stuff. X-ray diffraction also be very useful because I said these thin sections were taken from the A horizon, B horizon, and C horizon. If we could look at zircon concentrations, so if you have zircons are a very resistant and stable mineral, you'd assume they'd be evenly distributed throughout an outwash deposit, and if we can look at them in the C horizon, then we saw on the B horizon there's clustered, the concentration's greater, that would show that we've actually had like some void collapse. So if we've dissolved those carbonate minerals and created big pores, and if those pores collapse, we could see some evidence of that. And that would actually tell us that the land surface has actually gone down. So kind of interesting. That would be some fun stuff to see. Flash the references, and thank you very much for your attention. I really enjoyed presenting today. It's exciting talking about what I've been doing for the last 3 years, and I welcome any questions or comments and any discussion. So thank you.
Questions for our speaker? He did a good job, but he didn't do that good a job. It has to be right. Sure.
I gather you did not do any X-ray diffraction to look at clay mineralogy?
No, sir.
Okay, but you did have some differences in clay, and I think you mentioned at least one of your profiles you saw an argillic horizon?
Yeah, 3 profiles. One at each of the 3 locations. There was argillic horizons, yeah.
Okay. So the presence of those argillic horizons implies some pedogenesis,
Mhm.
formation of some secondary clay minerals,
Mhm.
which would be sort of your null hypothesis,
Alternative.
your alternative hypothesis.
Mhm.
Would you care to discuss that and what you would do a little further on to look at the role of clay minerals and clay mineral formation in these sequences?
Yeah, of course, you could get a better idea if you had more cores. And I kind of wonder, how, so when the outwash is being deposited, especially, we assume it's kind of a random distribution of many different things. So what if we had just a cluster, because if you have a random distribution, you have clusters, and then where there aren't clustered stuff. If we had a lot of lime, with those impurities that I mentioned, clustered in one area, just by random chance, and maybe they hit that, one of those 3 cores, where you've dissolved that out and you actually you've had more clay to form that argillic horizon. That was actually studied in that a paper by Rosted, Smeck, and Wilding in Ohio, where they studied the formation of argillic horizons from calcareous gravel deposits. And they had similar high amounts of carbonates, but higher. They had like 40% carbonates by mass and 60% carbonates by mass in some of their studies, and they formed really nice argillic horizons because all those impurities is what they chalked it up to. As far as, I guess I don't know how to look at what other minerals might be breaking down to make those secondary clays. I haven't thought much about that from outside of that perspective, I guess. So, okay, is that kind of answer?
Yeah, I think.
Do you have suggestions how we could maybe investigate?
Well, one
that?
thing you could look at is your more resistant minerals like quartz, relative to your more rapidly weathered
Yes,
phases,
certainly.
mafic minerals,
Mhm.
and see if those ratios change as a function of depth or
Mhm.
in correlation to the mineralogy or the clay mineralogy.
Yeah, certainly. That would definitely make sense.
Certainly identification of smectites, kaolinites, as opposed to clay micas,
Mhm.
would give you some indication of secondary
Yeah.
mineral formation.
Yeah, kaolite, of course, usually being like the second
Weathering
mineral.
product,
Yeah,
yeah.
weathering product. Yeah.
Just a couple of thoughts.
Yeah, thank you very much, Dr. Larry. Amber, yeah.
So, because we know that outwash can change properties fairly rapidly over a smaller area, you had the finer textures on the Avon Lake and pretty significant differences in textures across years. Are you attributing that to just geologic, like where it was in the deposition process, or are you attributing it to that, or to a combination of factors?
If I understand your question correctly, I think you're asking, am I attributing the fine textures over the coarse textures strictly to the deposition, the energy regime and deposition?
Deposition, or do you think that there could be other factors involved? Like if you had sampled in a different terrace, would you expect to find something different, or?
There's been good work in Iowa correlating the terraces of the Des Moines River. Bettis, for one, has done a lot. Art Bettis at University of Iowa, and he points out that the high terraces along the Des Moines River, what he calls the high terraces, that oldest terrace that's outwash. So there isn't really documented, to my knowledge, a lower terrace that has outwash. So at a lower elevation, and they've been correlated from northwest to southeast Iowa. Now, something though that you're making me think of. So I wouldn't expect to see much of a difference, basically. Now, if we were talking about an outwash plain away from the river, who knows what to expect? That'd be interesting. However, let me actually show you. So just something that you're making me think of. This is some bonus slides. This is actually the Howlett location, and you can actually see evidence of the braided stream from the Des Moines River when it was like a glacial river, and it had all that heavy load. Now, we might see some differences as we move across these like kind of micro topographic like differences. It's not a very big change in elevation across this terrace, but you can kind of see these channel bars, and there'd be just a little bit different energy regime when that glacial meltwater is flowing over. So you could see, and this was seen in a couple places where you had a little bit more gravel than you had. You'd see drops in gravel, so higher energy where you had like a good channel bar. There was a little bit more gravel, including closer to the surface. Versus if you're in between those bars, I'd expect you'd have like less gravel because of lower energy. So I'm not sure if I was getting what you're asking, but
That was the sort of variation.
okay, sort of so kind of this lateral variation that might.
Yeah,
occur,
how much are you attributing to each of those things?
Yeah. So, thank you, Amber.
Well, you tried to correct for that in your field work to not
Yeah.
collect one location. at
Yeah,
one-
no, I didn't choose like preference. I tried to go across the landscape more or less like almost randomly but evenly, and I wanted to sample most of the outwash map units that were listed to get a good sampling of all of them. So you might have a summit, a couple summits and a couple shoulders and a couple like foot slopes. But these aren't really true summits, shoulders, and foot slopes. Like it's very low relief. We're not talking like this summit and then this foot slope. So these are like, I'll call them like micro foot slopes and stuff. So I'm trying to encompass some of that variability. Yeah, that was our approach. So yes.
And that one, in your first slide, you had showed different features, like esker and,
Oh, yeah.
and cattle and stuff.
Sure, certainly.
Did you happen to notice anything like that?
Oh.
Especially cattle?
I wasn't really, you mean when I was traveling
Did you
about?
happen to see anything that might have been?
I didn't see any like kettle lakes, and I mean some of our kettle lakes would be drained, right?
A lot more drained.
Yeah,
but they'd be more upland.
And they'd be more upland, yeah. And I wasn't journeying across the end moraines so much. So no, to that answer, I didn't really see those, but I wasn't looking for them. I was looking at, before I even went out and journeyed somewhere, I was looking at LiDAR imagery to see good terraces, and I was also looking at superficial geology maps provided by the State of Iowa Geological Survey, where they mapped the outwash terraces. I guess I didn't get adventurous enough. I was kind of tunnel vision scientist, eyes to the ground, and yeah. So, but thank you for the question. Yeah, I'm always, when I'm driving around Iowa, looking out the window and trying to, that looks like an esker, and I have seen them other places, but not near my study sites, so my study locations. Dr. Haas, you had a question?
Yeah, can you go back to slide 41?
Yes.
Your bonus slide.
My bonus slide. Yeah, and I have more.
Okay, so I assume you're implying that this picture in the upper left is a modern analog
Yeah. This was actually the Platte River,
Platte
if I
River.
remember correctly. Yeah, the Platte.
from Colorado.
Yeah. Actually, you know what? No, I'm not sure that's the Platte River. Let me not say that because, yeah. But in modern day analog, kind of a braided stream. Yeah.
So if you were going to go to find similar deposit of age 0,
Mhm.
that's the place you would go?
Actually, I would go to say, there's a paper I read by a guy named Vierick who studied up in Denali
Okay.
National Park in Alaska, and there's some good outwash terraces. Let's see if I can, do I have any slides? I must have deleted all those out of here. Sorry. There's some good outwash terraces there. That would be a good analog, I think. You have some mountain glaciers, and you have a glacial stream coming down, and you hit this outwash plain, and you start cutting these valleys, and you're depositing the outwash, and there actually in his study, he has 5 different aged outwash terraces, because the ice age, so to speak, didn't end because you have high mountains, and so those terraces don't change to alluvium.
Okay.
You have out. That would be a good. That's where I would start. Not. I mean, maybe in Colorado, if you got close to the mountains, and you knew there was it was coming straight from glaciers.
Okay.
Okay. Is that?
Do you think the composition of the sediment particles would be similar up in
Like
around
lithologically, mineralogically
yeah, would you
speaking?
still have the same distribution of lithologies?
No, I wouldn't think so, because that is totally controlled by what the glacier is moving over and scraping up. What's that source region? So in different parts of Ohio, where you had the different ice flows, you see different compositions of the till, and likewise you can see different compositions of the outwash. So yeah, that's kind of like a complicating factor. Also, when I mentioned that bulk density for outwash, that was hard to find. One, not too many people have published that. And then two, I had to go to Washington State to find some numbers in a paper from Washington State. And I 1.6 sounded like a good number, but man, you know, and it's supposed to be fresh outwash in their study, at least I believe it to be. But the different lithologies mineralogies could make a big difference in the bulk density even. So if you have different particle size densities, packing, etc. So, yeah, does that answer your question?
Yep.
Okay. Dr. Manu.
Yeah, I see some of the distributions of your, those properties.
Mm-hmm.
It does not show any special trends in most of them.
Sure.
How do you account for that?
So the trends where it varies across like the state of Iowa, you're saying? Or?
Now you can see, for example, your locations,
Mm-hmm.
you plot clay,
Yep.
and it's all zigzag. I remember in my graduate student days, I used the term erratic, and I got in trouble. So I'm not going to say erratic,
Okay.
but it does not follow the normal clay distribution that we see in other soils.
Okay.
So what can you say about that in terms of the morphology of these soils?
Okay, so you're saying that the clay
Or
amounts
maybe not clay only, but
Okay.
a lot of your properties.
differing from, say, other soils across the state.
Mhm.
How can I account for that?
Yes.
I mean, I think parent material makes a big difference in this state. Big difference because of our mesic climate, etc. The geology is really controlling. Now, say if we were maybe in, say like South America rainforest or maybe Ghana, I don't think the geology would have big of an influence. And then we would see maybe even if it's a soil being formed from a granite versus a basalt, that the soil somehow ends up looking similar at the end. So I'm thinking that the differences in morphology are largely inherited from the uniqueness of that outwash parent material. For example, man, I almost saw no redox features because, I mean, outwash has such good drainage, especially at depth. I mean, it's moderate drainage near the surface where you have those more loamy textures at these sites, but very good drainage below. So they're not tiled, and so, I mean, that's one thing. And then the clay, I'm really chalking that the clay accumulations up to, you have some starting amount that's similar to the sea horizons, like around maybe 12%. And then you're really releasing some when you're dissolving these carbonates, those clay-sized impurities. So, and yeah, does that kind of touch on what you're asking?
Well, can it be tied to, your waning? You use that term, waning.
Oh, the waning flow.
That's right.
Yeah, I mean, that would make sense that also too, yeah, of course. If we have that, if I'm saying that Noah Creek Formation has that coarser gravelly deposit, and then we're interpreting that waning flow deposit, less gravel and stuff, well, it's lower flow, you're gonna deposit more silts and clays.
Right.
And you're gonna deposit less coarse sands and gravels. There were still pebbles and some coarse sand, but it dropped versus what was blowing. So yeah, so that would also, yeah, of course, explain some of the increase. Is that also, because I was showing that in those A horizons, those A mass horizon across all three locations, clay was around like 24-25%, and that probably is that kind of waning flow. Yeah, you can deposit more of that finer stuff, finer particles. Yeah.
Thank you.
Thank you for your question, Dr. Laird. Yes.
Yeah, if I remember correctly, one of your early slides, you were showing the lithology of the coarse fragments. And if my memory serves me, you had concretionary or iron minerals.
Concretions?
Yeah, that was like, what, 17%?
Yeah, and this is from, yeah, it was pretty, let me see. There it is.
There it is.
Yeah, this of course is not my data. This is from the U.S. Geological Survey. Yeah, these iron oxide concretions, I think why there's so many is one, the source region of the ice moving over the pure shale, so like in the Dakotas. And this is, I mean, I don't know enough about these iron oxide concretions, but they must be pretty resistant, so they're not getting
I
pulverized.
got one in my office, it's about the size of an orange.
Sure.
And
I pulled
I've
some
seen
out
it in
of
these
some of my
outwash
cores.
deposits before. And so are those pedogenic or geogenic, and what are they doing there in the first place?
Those concretions?
Yeah, I don't get it.
I think they should be geogenic. I think they form in the shale. The shale, I mean, the shale is probably pretty deep, and so there's some fun things going on in there, and I'm a little bit rusty on some of my geology, I guess, even though I'm a geology major, or was. But yeah, I think that you're having some interesting chemistry going on while that shale's sitting there, and you must have some things moving in and oxidizing some gradients, and you grow this structure. And so I guess I'd call that geogenic, and I'm sure it's influenced by groundwater flow.
So you think it's all inherited from the pure shale?
Yeah, I would say, yeah. And I actually, like I started to say, I found what I call these same things. I found some of them in some of my lower horizons, and they're often broken up. But I think the biggest one I found was maybe that big, and it was split in about a half or maybe quarters. So yeah, it was kind of neat to find that. I'm like, hey, that's the same thing they said I should see. So,
Could you see any coarse material inside the concretion?
I did not. I did not. I did not notice that. No, it looks like fine. So yeah.
So that might imply it grew in a shale, rather.
Yeah, it grew in a shale,
And then
right,
it grows out.
right. And there's definitely the nice different colors. It was kind of like well, not like an onion. Onion doesn't have different colors inside, but
It should.
yeah, it shouldn't. Yeah, don't eat that onion.
Questions from the general audience? Because I know the committee has a series of detailed questions they would like to ask. Thank you, Ethan. Very good job.
Thank you very much.
So for the committee, we'll take like a 3-minute break. And for everyone else,
Grab some cookies.
grab some cookies, fruit, that's healthy to have. And then there's some orange drink. It must be healthy, it's orange colored. So do that, and then we'll continue. Just a few of us here.
Thank you all for coming out. Thank you. Thank you very much, Dr. Larry. Appreciate it. Very good turnout. I really appreciate everyone coming. It makes me feel valued.
Yeah, you better shut that off.